So this question here, we've got an average diameter of a bolt made in a factory is 13 millimeters. And the variance, according to the specification and the history of these bolts, the variance is 1/100th of a millimeter. Now we want to know the probability of a bolt chosen at random to be 12.8 millimeters or less, and the probability of a bolt being between 12.9 millimeters and 13.1 millimeters. So when we've got an average and a variance, we could say that these bolts here will follow the normal distribution. So if we say the diameter of a bolt is randomly distributed normally, and it's mu, comma, sigma squared, which is the variance. So therefore we could translate that as D is normally distributed, the mean, so the average bolt diameter is 13, so that's 13 millimeters. I'll write 13 millimeters there. And the variance is 1/100th of a millimeter. Okay, now from that we want to try and find what our standard deviation is. So standard deviation is going to be the square root of that. So standard deviation is the square root of 1/100, which would be 1/10, and that's millimeters. So now what I can do is I can draw a little graph with my normal distribution curve and see what's happening. So my mean is 13, so if I put that in the middle somewhere, and then I've got 1/10 of a millimeter with each standard deviation. So I'm going to draw up the three standard deviations across. So it's 13.1, 13.2 and 13.3, and then that's 12.9, 12.8 and 12.7. So this is three standard deviations less, this is three standard deviations higher. So with this being my mean, my sketch of my distribution will look something a little bit like that. So what we want to know is the probability of a bolt chosen at random is 12.8 millimeters or less. So 12.8 millimeters, that's what we've got there, or less. So what we're looking for is the area under the curve in this position here. So to be less than 12.8 millimeters is going to be quite small. So what we want is probability D is less than 12.8 with this distribution set up here. So if I'm going to write that, so D is distributed normally 13, 0.1 squared. So if I write it like that, that's equivalent. So if I plug that into my normal distribution CD function on my calculator, we'll get approximately 0.0227, which is about 2.27%. So therefore my probability of getting a bolt that's 12.8 millimeters or less is 2.27%. So that's that one there. Now the next one is probability of a bolt between 12.9 and 13.1. Well, that's 12.9 and that's 13.1. So the area here, that's going to be quite a big number. So I'm expecting the probability here to be quite high. It looks like the chances are quite good. So what we're looking for now is the probability of 12.9 and D and 13.1. So D is in between 12.9 and 13.1. So for that, you'll have to go to your normal distribution calculator, CD, and set your lower tail to 12.9, upper tail to 13.1. So that's lower tail, upper tail, that's the mu, and standard deviation 0.1. So put that into your calculator, you should come out with around about 0.6827. So that comes to about 68.27%. So that's our probability here. So I'm going to write that, let's write that there. So that is the answer and how to get there with these two examples. Okay.